Okay, so this is section 7.1 and finishing up 7.1, this is example 7, the last example on your notes. And nice little word problem here. We're going to Disney World. How about it? Um, let's read the problem. It says the density of cars on 10 miles of the highway approaching Disney World is approximated by this function, where x is the distance in miles from the Magic Kingdom entrance. Find the total number of cars on this 10-mile stretch of highway. So I picked up in the reading that x was miles, the distance from the entrance of Magic Kingdom. I also read that the density is approximated, so f of x really is a density function, and it's density of cars, and they also mention miles. So I'm thinking my label would be something like cars per mile, the density of it, right? Now, let's go to our calculators because I don't have any idea of what this really looks like, and let's map it out. And to do that, grab your calculator and let's go into our y1 equation and put in the function f of x. I didn't really have a clue. Well, I had a little bit, but in order to get my best picture, I hit zoom and did option, it might be option 0, the zoom fit one. And that got me a graph that gave me a look at what my function, how high it got. I knew from my x values that I probably want to go from 0 to 10 because I want to capture the first 10-mile stretch coming out of the Magic Kingdom. So when I set my x and y, my x min, my x max, I could have set it from 0 to 10. I just chose mine. I've got set from -5 to 15, and I know I'm counting by 5s because that's what I set my scale at. I also, when I did zoom fit, found out that the function went up to like 900 and something. So I said, oh, you know what, I'm going to go from 1,000. So I'm going to go up to 1,000. So I did 0 to 1,000, and I'm counting by 100. So a tick mark's going to occur on the y-axis every 100 units. So let me get rid of that. We don't need that anymore. So play around. Get really comfortable playing around with your window so that you can get a graph that looks pretty decent. I'm going to swipe this graph off. Okay, so where does that take us? Well, how does that get me the number of cars in the first 10 miles? So there would be 0, 5, and 10. This would be the 10-mile. This function, f of x, is a density function. And we're going to keep in mind that this was cars per mile. Now, another key word that I read when going through this, or that popped in my head that meant something, was total. And in calculus, getting the total of something is a lot like accumulating. Accumulating one car plus 5 more plus 10 more. I want to accumulate. So this is an accumulation of cars. And the best way to accumulate in calculus is to use an integral. So I'm going to say my total number of cars on the stretch 0 to 10 miles is my f of x function. So 184 minus natural log of 2x plus 3 dx. What is it going to be calculating? Well, remember, this was the density function. So this is cars per mile. And dx, the differential of x, well, x was miles. This will be a label that comes in as miles. And I get miles, cancel miles. My answer is going to turn out to be in cars, which woohoo, that makes me happy because I want my answer to be the total number of cars on the road accumulating through this function. And that is something I really don't want to integrate by hand, so I'm going to let the calculator do it. This is a great application for the calculator technology. So there's 2 ways I can do it. I'm not sure we've talked about area under the curve. Once I'm on my graphing screen, I can go into calculate. So it takes a second trace to get there. And notice option 7 at the bottom talks about the integral. Notice here it's saying lower limit. My lower limit I want to set at 0. My upper limit I'm going to set to 10. And then it is going to, ooh, with this color, that's so sweet, isn't it? There we have it. I have an answer to our question. 2,806.152 cars on the road is our estimation of the total cars on that 10-mile stretch. 2,806.152 cars. And for the AP, we just always give them 3 decimal places unless it's very clear in the problem that they want us to estimate or round to the nearest whole car. So there you have it. Now, could I have done that on the home screen instead of under the curve here? Absolutely. If you can go to the home screen, you can also go into your integration option 4. I want to go between 0 and 10 miles. And I want to work with my y1 function so I don't have to repeat. Whoops, didn't get the right value in there. I'm trying to capture y1. And that is found by going alpha F4. There's y1, dx, and enter. We should get that same number that we had before, 2806. Perfect. That's all that there is. Now, homework is following, and you have 2 days to work on this homework and use your notes. And your calculator some too, but there's some of them you should be able to do by hand, and some it'll be obvious you probably want to use your calculator. Good luck.